Good morning, my dear students. We are going through the very important lesson of periodic classification of elements, right? So, the classification of elements started with the work of Lavoisier, then Goldberg, after that Newland, then Mendeleev. Mendeleev is called as the father of chemistry, right? Because he made scientists to invent new elements. So, Mendeleev formed the periodic table. After that, Moseley. Today we are going to study about two topics. One is how to write the IUPAC names of the elements, and then what is the Moseley's modern periodic law and the features of modern periodic table, right? So the IUPAC names of the elements were first written with atomic number. So atomic number is used to write the IUPAC elements, right? So in this IUPAC atomic number, we have digits. These digits, there will be at least 10 digits from 0 to 9. And these digits are named like this: 0, nil, 1, un, 2, bi, 3, tri, 4, quad, 5, pent, x, 7, sept, 8, oct, 9, n. In this, two things which are changing are these two. Generally, all these things are used in the rest of the signs, right? So always we use nil for 0, uni for 1, bi for 2, tri for 3, quad for 4, quadrilateral so no, pent for 5, and hexa for 6. This is generally called as hepta, but here it is slightly changed to sept. And octa is common. 9 is called nona, but here also it is changed to n because of the symbol. The first letter is taken as the symbol for this particular word. Therefore, if it is hepta, we will get 2h. If it is nona, we will get 2n. In order to avoid that, these two words are changed, right? Particularly 7 and 9, you got to be careful, right? So first we write the atomic number. So using the atomic number, name is written with this 10 words. For example, if this 108, right? What is that? Name of this element. 1 is written as un, and 0 is written as nil, and 8 is written as oct. And third thing, the suffix is always ium. So it is octium. So these are the three rules which are used to write the IUPAC name. So un, nil, octium, right? So always the suffix will be ium. And the symbol is written by collecting the first letters. The first letters of each number word is written as the symbol. So for 108 element, the symbol is UNO, because it is un, nil, octium. So like that you can write the IUPAC name of any particular element given the atomic number. For example, if it is 1, 1, 2, what is the IUPAC name? It is un, bium, right? What is its symbol? UUB, right? For example, if it is UQP, so what is the atomic number for this? This is un. U is the number 1. Q is the number 4. P is the number 5. So atomic number is 145. If you are given the symbol, you can write the atomic number, right? What is its IUPAC name? It is un, quad, pentium, right? Like that we write the name. If you are given atomic number, you can write the IUPAC name, you can write the symbol. If you are given the symbol, you can write the atomic number, you can write the IUPAC name. So in all the ways you must be able to do it. It's very simple. All that you got to know is these 10 words. If these 10 words for these 10 digits, if you know, you can write the IUPAC name, you can write the symbol. So this is very well used in the modern periodic table also, for especially for the new elements which are being discovered, right? And then we move on to the modern periodic law. This was work done by Moseley, right? There is physical and chemical properties of the elements are called, or periodic functions of atomic number. Atomic number மாறினா elements உடைய properties periodic-ஆ மாறும். Periodic-னா என்ன அர்த்தம்? Regular-ஆ மாறுது. Whether it will decrease or it will increase uniformly. That is called periodic. In school every 40 minutes there is a bell. Then period is changing. One subject to another subject teacher will go and learn. Like that here also, if the atomic number is uniformly changing, then the property of the elements will uniformly change. What is the reason for that? Because atomic number is the one which decides the electronic configuration. And the electronic configuration is the one which always decides the properties. Atomic number which is the electronic configuration. 1s2, 2s2, 2p6, 3s2, 9. And the electronic configuration which is either metal or non-metal, electropositive or electronegative, or what ionic bond will covalent bond will move. All these properties are being studied, right? So this is the base for the modern long form periodic table. So in the long form periodic table, what is observed? So Moseley arranged this long form periodic table. Here elements are arranged in the increasing order of atomic number, right? So elements are arranged in the increasing order of atomic number, and the elements which are placed in the vertical column are called groups. So vertical column na மேல இருந்து கீழ போறது. This is called group in the modern periodic table. For example, first group அப்படினா hydrogen, lithium, sodium, potassium, rubidium, cesium, and then francium. So this is first group, right? And there are 18 groups in the periodic table. Right? 18 groups in the periodic table. Out of these 18 groups, the first and second group elements, first group element is called alkali metals. Second group elements are called alkaline earth metals. Right? And the elements which are present from group 3 to 12 are called transition elements or D block elements, right? And then the elements which are present from group 13 to 17 are called representative elements. Because most of these elements represent the most of the compounds in the world. And seventh point is that the group 18 is called inert gas. Inert gases or noble gases. Because they don't react, they are the highly stable elements. right? This is about in short, this is a note that you got to learn about the groups. There are 18 groups. The elements present in the vertical column are called groups. There are 18 groups. First group contains alkali earths. Second group contains alkaline earth metals. Group 3 to 12 are transition metals or transition elements. And then group 13 to 17 are called representative elements. Group 18 is called inert gases. This is about the groups. And then we have about the periods, right? So the elements which are placed in the horizontal row is called period, right? And there are 7 periods in the periodic table. For example, the second period. The second period is like this. It starts with lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. So this is second period, right? So in the first period is called as the shortest period. Right? It has got 2 elements. In these elements, 1s orbitals are filled. 1s1, 1s2. There are 2 elements. First is 1s1, the second one is 1s2. And then the fourth point is about the second period. Second period is called as short period. This has got 8 elements. In this, 1s and 2s, 2p are the outermost orbitals that are being filled. This is having 1, 2, and this is having 1 to 6. So 6 plus 2, we have got how many elements? 8 elements, right? And then the third period is also called a short period. This is also having 8 elements. In this, 3s and 3p are being filled. So this is third period, right? It has got 8 elements. First one is 3-1 and the last one will have 3p6, right? And then 6-1. Fourth period is called as long period. It has got 18 elements, right? In this, 4s2 is filled, then 3d is filled with 10, and 4p is filled with 6. So 10 plus 2, 12, 12 plus 6, 18. So this is absolutely going according to the half-work principle, right? Then fifth period. The fifth period. So this first period is the shortest period. Second and third period are the long periods. And fifth period is also called as long period. Right? So this is also having 18 elements. Here it is 5s2, 5p, 4d10, and 5p6. Right? It has got the 18 elements. Then sixth period is the longest period. And this has got 32 elements. Right? This has got 6s2, then 4f14, 5d10, 6p2. So this is for 32 elements. But in these 32 elements, the 14 elements which are present in 4f orbital filling is taken separately and placed at the bottom of the periodic table as lanthanides, right? And the seventh period is also the longest period, which is supposed to have 32 elements, and that will be having 7s2, 5p, 5f14, then 6d10, then 7, 6, 5f14, then 7p, 6. So this is how it goes, right? So like that we have the periods being arranged. And there are 7 periods. In the 7 periods, the 14 elements, 6th and 7th period, the 14 elements from lanthanum and the 14 elements from actinium were taken down and placed separately. So overall we get like this. The periodic table will be like this. This is 1 and 2, this is 3 and 12, this is 13 and 18. So here it is S block, P block, D block, and this is F block, right? So this is how we have the long form periodic table features. So you should know completely about the groups, you should know completely about the periods, right? So this order is almost the order that is given in the half-puff diagram. So in the half-puff diagram, we have drawn like this, right? 1s, 2s, 2p, 3s, 3p, 3d, 4s, 4p, 4d, 4f, 5s, 5p, 5d, 5f, 6s, 6d, 6d, 6f, 7s, 7p, 7d, 7f. 1s is filled, 2s is filled, 2p, 3s, 3p, 4s, 3d, 4p, then 4d, 5p, 6s, after 6s, 4f, after 7f, 5f. So if you forget this, while writing the last 3 periods, it is better to use this like this. So first period only 1s, second period 2s and 2p, third period it is 3s and 3p, fourth period it is 4s, 3d and 4p. Like that it will go. So you can check with this diagram also, right, if you want. So today you should have learned how to write the IUPAC name, IUPAC symbol, and the rules for that. Then what is modern periodic table? What is the features of long form periodic table? All these are very important, right? So after this only mostly you will write your half-yearly examination. So keep studying this and you can write the half-yearly exam up to this. Okay, take care, God bless you.